Alright, I'm going to continue on from concentration and dilution. In the very first topic, this is what we didn't finish so far. So it says the ratio of solute to solvent in a solution is referred to as the concentration. So we talked about this before. Solutions with large amounts of solute compared to solvent are said to be more concentrated, while solutions with small amounts of solute compared to solvent are said to be dilute. And yeah, we've talked about this before, so if you look at this picture, the diluted one would be the one that's the clearest, I guess, the one you can see through the most, the lightest, and the more concentrated would be the darkest one. And that's, yeah, concentrated, it says high ratio of solute to solvents, so there's lots of solute, so whatever's making that color or that flavoring or whatever it is very high ratio, and then a diluted thing is very low ratio of solute to solvent. So concentration and the rate of reaction. It says chemical reactions are the result of collisions between particles. Because a concentrated solution has more particles available for possible collisions, then dilute solutions, concentrated solutions react at a higher rate. So the more concentrated it is, the faster it's going to react. We could think about that if I was to spray a perfume at the front of the room. It's really concentrated in that area and it's going to spread out fast. If it was a really diluted perfume, it would take a lot longer for you to be able to smell it, or you might not smell it at all. So the point is, more concentrated, more chance or higher rate that it's going to move around. So how we express concentration, there's three different ways, methods, and they're all calculations that I will teach you how to do in a second. So how we express them is by percent by volume. So basically the percentage of the whole mixture that is solute over the volume of the solvent times 100. And so this is a pretty easy calculation, and we'll do an example, I think, on the next slide. The second one is parts per million, and you may have heard this before. So the mass of solute over the mass of solvent times 10 to the 6 would give you parts per million. 10 to the 6 would be million. So how many parts are in a million particles, per se? That's what that means. So expressing the concentration of pollutants or toxins, we often use this as a way of saying how much is there. And we'll talk about that a little bit later. And the last one is molar concentration. And you may have done this in Science 10. I can't for sure remember, but we'll definitely review it here. This is the moles over the amount of liters of solvent. So the moles of solute over the volume of solvent. This is expressed in a concentration of solutions used by scientists and lab technicians. So we often use molar concentration in science. Parts per million, talking about pollutants in the environment. Percent by volume, normally in like products that you might buy. Okay? So the first one, how do we calculate things by percent by volume? Well, this is the formula that we use. So the V solute, which is the volume of the solute, and that's always measured in milliliters, divided by the volume of solvent, which is in milliliters, times 100 will give you that percent by volume number. So let's try one of those. So it says a hair product requires you to combine 20 milliliters of hydrogen peroxide with enough water to produce a solution with a total volume of 120 milliliters. Determine the concentration of the solution. Okay, so we've got some numbers in here. Let's try and pick out what each of these is telling us. So as I read through this, I normally like to underline what they're giving us, the pieces of information that are important. But remember our formula, if I go back to the last slide, It's the volume of solute over volume of solvent. So I'm going to write that here. Volume of solute divided by volume of solvent times 100. So it says in the question, a hair product requires you to combine 20 milliliters of hydrogen peroxide. So that's volume. It's hydrogen peroxide with enough water to produce a solution with a total volume of 120 milliliters. So there's some information here. We actually are going to have to do another small calculation, but let's pick this out. So 20 milliliters is hydrogen peroxide, and that's going to be mixed with water. Water is literally 99.9% chance is going to be the solvent. So right here, that's going to be water in our question, and right here, that's going to be hydrogen peroxide. Okay, so that is how we would calculate it. So if we're going to plug in this information, we've got 20 milliliters of hydrogen peroxide. That's going to go where our V solute is. So this part is going to be our 20 milliliters. Okay, divided by our solvent, which we actually don't know what it is. And the reason why it says in this question that the whole solution together makes 120. So if we have 20 milliliters of hydrogen peroxide, and our total is 120, how much of that is water? It would basically be 120 minus 20, which equals 100. So they're saying that 100 milliliters of that is water. Okay, so I'm going to just extend the page here for a second, rewrite this. So our V solute is 20 milliliters divided by our V solvent, which is 100. And to do this, we have to times it by 100. So if we calculate that out, our answer 20 divided by 100 should give us 20% or 0.20, I guess, and then we times it by 100 so that equals 20%. Okay? So if we look back at the question, how much of the solution is made up of hydrogen peroxide? Well, it's made up, 20% of it is hydrogen peroxide. Okay? Good. Let's do the second one. This is another 1% by volume. It says a mosquito repellent says that DEET makes up 45% of the total volume. If you have 75 milliliters sample of this repellent, determine the volume of DEET. So DEET in this solution would be the solute, making up less of it. Think of this one as always being the one that's less. Okay? So in this case, that's DEET. That's that good stuff in bug repellent that actually makes it work. And then your solvent, sorry, I was going to say solution. Is going to be the whole solution or the solvent. We don't know what the solvent is, do we? If you have 75 milliliter sample, so the whole solution is 75 milliliters. how much of it is made up of, or how much of it is DEET. So I'm actually not going to use this formula. Really, all this question is asking us is we have a 75 milliliter solution. How much of 75 milliliters is 45%? So I'm just going to times it by 0.45, and that'll actually tell us how much milliliters is DEET. So I just grab my calculator here. Sorry, I was sending you on a slightly harder way of doing it. But if we take 75 and multiply it by 0.45, I get an answer of 33.75. So 33.75 milliliters would be DEET. Okay? Hopefully a pretty straightforward question, but again, if you come across something like that, this was how you do it. And there's another example. So let's do this example. It says insecticidal soap is an environmentally friendly way to control insect pests on plants. A gardener needs a solution with a percent by volume concentration of 5%. If the total volume of the solution was 4,000 milliliters, I'm just going to write down some of the things as I read through it. Calculate the volume of the insecticidal soap needed to make this solution. So if the whole solution is 4,000 and we need 5% to be soap, this again, we're not really using the, we don't need to use that formula per se. We just need to find out what 5% of 4,000 is. So we can do that. We just go 4,000 multiplied by 5%. So put it into a decimal, or you could go 5 over 100, 0.05. And that'll tell us how many milliliters of soap we need. Well, not how many milliliters soap, how much milliliters of insecta soap stuff that we'll need in our solution. So it is soap. I'm not crazy. So if we go to our calculator, we use 4,000 multiplied by 0.05, we get 200. So if you're trying to make a 4,000 milliliter, that's 4 liter jug, you need 200 milliliters of it needs to be soap, and then the rest would be water. So 3,800 milliliters of water, 2,000 milliliters of soap, or 200, sorry. All right. Now let's do the second type of calculated concentration, which is parts per million. So ppm, this means parts per million. How we figure that out is we take the mass of a solute divided by the mass of a solvent and times it by 10 to the 6. Okay? So let's do an example of that. Let's see an example of this. So before I do this question, I'd just like to go back and solute over solvent. Make sure I have my formula, because I always forget. And then you're going to times it by 10 to the 6, because that's times a million, basically. All right, so the example says 200 grams of a sample from a bottle of water contains 5.4 times 10 to the negative 3 grams of mercury. So we've got actually all of the information that we need in that question. We've got the mass of the solute, the small thing, remember that's the small thing, which is 5.4 times 10 to the negative 3. grams, and that's of mercury. Okay? And you're going to divide that by the solvent. The solvent is the water, which is 200 grams. This is of water, and this one's of mercury. Hg is the symbol of mercury. Okay? Hopefully that's not too confusing there for you. So if we divide those two numbers and then multiply it by 10 to the 6, we should get our answer. And I don't have a proper calculator to do that. Just give me 1 second. .4 second function. So if I do that on a calculator, I get an answer of 0.000027, and then I need to multiply it by 10 to the 6. And if that confuses you, what you can really do is move the decimal 6 places. So I'm going to do that just to show you what it would look like. 1, 2, 3, 4, 5, 6. So my answer is actually 27 parts per million. Okay. So that's answering letter A. Letter A is calculating the concentration of mercury in the sample. Our second job here, it says the maximum acceptable concentration of mercury in drinking water as established by Health Canada. Guidelines is 0.001 parts per million. Is this sample above safe to drink? And the answer would be yes. So for B, we would write this sample is not safe to drink. Another example here, it says carbon monoxide is a deadly gas that prevents oxygen from being properly transported throughout the body. Individuals who smoke typically contain a concentration of 200 parts per million of carbon monoxide within their lungs. Determine a mass of carbon monoxide that would be present in a single inhalation of cigarette smoke, which has an approximate mass of 9.6 grams. So if we look back to our formula, we've got solute, our mass of our solute, over our mass of our solvent, times 10 to the 6. And what does that all equal? Well, it equals, what does it equal? Our parts per million. I'm just going to put an X there. Try and extend that. So if we're going to calculate this, let's plug in the information that it gives us in the question, and then we can figure out our missing part. Because this question gives us 200 parts per million, we actually have this piece of information. So I'm just going to try and write this below. We have 200 parts per million is equal to, well, 10 to the 6 is always going to be there. And then this is possibly where we're missing a piece of information. So if we look at this, we've got a mass of 9.6 grams, which I'm just trying to figure out if that would be, it says determine the mass of carbon monoxide that would be present in a single inhalation of cigarette smoke, which has an approximate mass of 9.6 grams. So our solvent is 9.6 grams, because that's our whole inhalation that we have. Our solute would be the amount of carbon monoxide that we're taking in, but we don't know that number. We're not sure what this is. This is the part that we're missing in this question. So what we got to do is we're going to have to solve for that missing part. So I'm just going to go ahead and do that. So what I would do here is I would first take this 9.6 and multiply it by 10 to the 6. So multiply by 10 to the 6. And obviously that would give us 9.6 times 10 to the 6. So if I cross multiply here, that's what I'm doing. I get 9.6 times 10 to the 6 divided by, we don't know what this is equal to 200. Now I want to get rid of that, I should call this X. We don't know what that one is, but we need to solve for X. So if we to solve for X here, I like to move X to the top. So to get rid of X on the bottom here, I gotta multiply both sides by X. So that will get rid of it on the bottom, and it'll get it over there. So what we have left is 9.6 times 10 to the 6 is equal to 200x. Now we want to get rid of 200, so we can leave x by itself. So this ends up being 9.6 times 10 to the 6 divided by 200. So they're both, that would cancel out. We've got x by itself. This divided by 200 gives us 48,000. So yeah, I'm looking at this wrong. Okay, so now that I've taken that times 10 to the 6, I guess I had to also put it to this. So this 48,000 actually gets divided by 10 to the 6. And our answer is 0.048, and this is grams. Okay, so in every inhalation of cigarette, you're getting 0.048 grams of carbon monoxide. Okay. Now, the last one over here, we're doing a calculation of molar concentration. I'm going to just skip right through to the example here. Our molar concentration is always, our concentration is equal to moles over liters. Sometimes I write C is equal to N over V. I don't know, I prefer writing it this way, so I'm going to show you it this way. So it says a sample of water taken from a nearby lake is found to have 0.0034 moles of salt per 100 milliliters. So I've got a mole amount, I'm going to plug that in as 0.0035 moles. And it's all over liters. They gave us a 100 milliliters. We're going to have to change this into liters. How we do that is we move our decimal 3 spaces to the left. So that's actually 0.100 liters. So 0.100 liters. Determine the concentration of salt in the lake. So if we divide those two numbers, we will get the concentration of salt in the lake. So we take 0.0035 divided by 0.100, and that equals 0.035. So our concentration is 0.035 of salt in the lake. Now let's try the last one here. Did I go backwards? So sometimes it says here that if we want to find the molar concentration, sometimes we have to change something into moles if it's not provided. The number of moles present in a compound or element can be calculated using this formula. N is equal to the mass divided by the molar mass of the substance. Okay? And you can find the molar mass of a substance on the periodic table. So this is something you did do in Science 10. Let's do a practice of it. It says a mass of 30 grams of sodium sulfate is dissolved into 300 milliliters of water. Determine the concentration of the solution. So if I go back here, we're using N is equal to little m over big M. So mass of the substance divided by the molar mass. So I'm going to write that here. Little n is equal to little m over big M. And big M in this case is our molar mass. Molar mass. And this is the mass. I'm just going to say mass given. So if we divide those two, we can calculate the moles. So let's do that. So we've got 30 grams given of sodium sulfate. It gives you the symbols for that, Na2SO4. There's a lot of things we need to calculate there. I'm just going to, I'll write it above here. So first of all, we have Na, we have S, and we've got O. Our first thing here is Na. Our first job is to look at the periodic table and see what the mass of it is. It says 22.99. That's 23. I'm just going to round it up. If you notice in the formula it says Na2. That means there's 2 sodiums. So we've got to go 23 times 2 plus, we need to do sulfur. There's only 1 sulfur there, there's no number below it. So we just look at what the periodic table says for sulfur. The periodic table says that it's around 32. I'm just going to keep whole numbers for easy sake. Plus the mass of oxygen, which I'm going to run out of space here. Just going to write it down here. Oxygen, which we've got 4 of them. And if we look up, oxygen is 16 times 4. You did this in Science 10. This is a refresher. So what we need to do is we've got to calculate this. We've got 23 times 2 is 46. I'm going to write this just above. 32 times nothing, so we still have 32. And 16 times 4 gives us 64, so I'm just going to write that there. So we got to add those green numbers together. We got 64 plus 32 plus 46. That gives us 142. Okay? So now that is the mass or molar mass of sodium sulfate. Big one. So let's get back to this formula where we're going to write our molar mass on the bottom. We figured it out to be 142 grams. And now we can calculate that. 30 divided by 142 will give you 0.211. Keep a couple digits. I'll maybe put that as a 3. It's 26, so I'll round that up to 3. And that is our moles. Okay? Now that we have that, we can use the formula we used on the previous slide to calculate the concentration of the solution. We've got moles. In our question, we have liters, so then we can figure out concentration. M is equal to moles over liters. Our moles are 0.2113 divided by our liters, which we go back to the question, it says 300 milliliters, which if we change that into liters, is 0.300 liters. So calculate that out. 0.2113 divided by 0.300 gives us 0.704. And that's big N, that's called molarity or concentration. And this is of Na2SO4. Okay, that's a long question. There's a couple steps there, but it is a good example for you. The very last one there, I'm not going to do the dilution right now, just for time's sake, because I've got to leave, but I will do the concentration or the diluting solution part. I'll do an example of that for you when I come back on Monday. Have a great weekend.